In 1780, Luigi Galvani discovered that when two different metals, copper and zinc for example, were connected and then both touched two different parts of the nerve of the frog leg at the same time, they made the leg contract. He called this animal electricity. The Voltaic pile invented by Alessandro Volta in the 1800s is similar to the galvanic cell. These discoveries paved the way for the electrical battery. The materials needed for the construction of the cell are two metals, in this case copper pennings and iron cylinder rings, an electrolyte like salt and water or vinegar, paper that will be cut into small pieces, safety gloves, rubber bands, and a small plastic bin. Having previously cut the paper into small sized squares, we will set a piece of metal, then a piece of another metal like shown here, alternating between copper, paper, iron, and so on. Afterwards, we will put our battery in the plastic bin and proceed to pour our electrolyte over the cell. Then, we will use a voltmeter to measure the amount of electricity produced by the battery. The science behind the experiment. Even though the appearance of the cell is simple, the explanation of its functioning is far from it, and it has motivated great scientific activity from the 19th to 20th century. These batteries basically are two metallic electrodes submerged in a liquid, solid, or paste called electrolyte. The electrolyte is an ion conductor. When the electrodes react with the electrolyte, the negative electrode, also called anode, produces electrons via a chemical reaction called oxidation. In the positive electrode, also called cathode, an electron deficiency occurs, a reduction reaction. When the electrons pass from the anode to the cathode via an external conductor, the cell produces an electrical current. This is basically an oxidation-reduction reaction that occurs simultaneously.